Thanks to everyone who came today and who will come today. Let's not lose any time. So I'll just jump straight into it. No, not straight in. Maybe one more thing to mention before it. Let's treat it more as a conversation, ideally, rather than a lecture. Because again, we will release the YouTube recording. Nata, you'll share the link to the GitHub, so you'll have all the code right now to launch it. So, you know, the content itself is for free. You can check it. You can summarize it with your favorite chatbot in one sentence and, you know, done. But if you're about to spend next 1.5 hours together, let's make the most out of the interaction, not just out of the, you know, content that you can read any day, anytime, etc. And I want to start with examples of what are the agents, because I think we have really mixed up understanding what is the language model, what is AI, what is an agent. And I really would like to separate those definitions. So one of the goals for this webinar is to bring clarity. And typically, you know, experience that when you chat with your favorite chatbot, you can ask questions, it gives you answers. But sometimes you want it to do more. You want to not just ask question, but you get something done. And simple example of such a task can be, you know, you're a football fan and you're not interested in general rules of the football. You want to know what are the results of the recent games and you want to save them as the CSV. Maybe you want them to get emailed. Maybe you want them to be shared with your friend. So this is something that is a little bit more than just, you know, typical ChatGPT conversation. And I'm offering you here, and again, Nata, can you please share the link? You already shared, yeah.
Yeah, already.
Yeah, so you can follow with me. You can open this notebook, 0 introduction. You can follow the same links and everything the same what we're doing here. So we can ask the same questions in ChatGPT, which we can consider as a baseline, and in couple of things that you can Google as agents. So if you Google LLM agents or something like this, you'll find, of course, Agent GPT, you'll find Evo Ninja. So let's ask those agents just to do this task. So parse the results, and let's see what it's going to do for us. And I'll ask literally the same task of to Agent GPT. I'll call it parse GPT. And I think the very first difference that we can see, even just visually, without knowing any technical details about what is agent, what is large language model, we can see some kind of notion of thinking. So we can check that you see here, Evo is trying to find the best agent to execute the step, which is analyzing which function should be called. So it shows some signs of thinking and reasoning. And the same here, you see it's adding the task. You see, for example, immediately Agent GPT decomposed our request to 4 different tasks: retrieve, parse, format, save. And it starts doing it. You see it's giving you some trail. Okay, it parsed, found the website. It got some results. It starts executing something. It's giving you a lot of different reasoning. It's even start writing the code in its own head. So it immediately does a lot of things that you can even, you know, double check and study what's happening inside. And you see here, Evo is obviously a bit slower. It's just starting to do web search. But when we study the reasoning of Agent GPT, for example, I can already see what I don't like. I don't like that it's hard coding the results. For example, in my head, I'm thinking about a bit more generalized parser. There's not just hard coding the results from the games in the code. It should do it, you know, automatically and have some kind of data stream. So, but at least it's good that I can study it, I can see it. But another question is, where's my CSV? So it seems like this agent hasn't really done the job I asked it to do. I was running the same task a little bit earlier, and for example, this agent, it actually creates the CSV. So I also can see the details of the steps. You see, it does the web search, and step 3, it actually will generate the CSV that will look almost correct. So this is something what a simple agent can do already. You can already play with it, but as you can see, it doesn't really do how we are thinking. So this was basically my personal motivation to start diving into agents, because it seems like the ready ones are not really thinking the way I would like them to think. So I decided to start diving deeper. There are a couple of more complex examples on the market you can find. For example, GPT Engineer. Maybe you know about this one. This is the bot that supposedly can write the complete applications for you. You just, give your key, and it will start the same reasoning, decomposing the tasks, start writing different pieces of code, then merging them together. And I think the quintessence of what is the agent is in really complex tasks like scientific research. And if you check this paper, it also has a nice visualization of, let's say, emerging architecture of the agents. We can see it somewhere here. So you can see it is just a language model, but it's empowered by many different tools. For example, general tools, like to be able to do search in the literature, in web, to read the code, to do some genetical operations. There are molecular tools, what we have, expert design chemistry tools, and different actions. For example, synthesis, procedure prediction, execution on a physical robot. So different things that a researcher would do. So it is a large language model, but it's empowered with many different things. And as we see in these agents, it's really important how do you structure those interactions between the different kinds of memories, different kinds of tools. How do you set up this logic? So the purpose of this webinar is actually to learn how to do it from scratch. And if we want to summarize the evolution from LLMs to RAG and from RAG to agents, we can see it like this. So language model is just, prompt and answer, simply like this. With something what is RAG architecture, if you know it's a retrieval augmented generation, first we retrieve the relevant context from some kind of database that it's already vectorized. Then we augment these retrievals, this pooled data, with your prompt, and you generate the answer. And of course, you can repeat it in the chatting mode. An agent is, at least in the current understanding, is the ultimate extension. So you have a prompt, you have some answers, we have some memory, but the notion of memory is generalized. In Illustrator today, it is we can build connections between even our brains, short-term memory, long-term memory, working memory, sensory memory, etc. There are some tools that we can use, just like us humans can use some kind of external physical digital tools. And there is a reasoning that orchestrates these interactions between the prompts, memory, tools, and even can impact the reasoning itself. And often we don't want just a result, we want an action. And this action can be done in digital world or in physical world. Many things that you'll see in this article follow in this really good Lilian Wang's blog. So I recommend you reading this afterwards, or maybe you're already familiar with it. And the question I want to ask you right now, what agents do you know and maybe you are already using?
Yeah, that's working. Great.
Oh, skill agent. This is really useful one. None. So maybe today you'll be able to, after or during this meeting, you'll be able to build your first one. Perplexity, Gemini. I'm also curious, maybe you can add details. With Perplexity and Gemini, do you use them as the agents to actually act on your behalf? For example, save some file, write the email, automate something, or use them as language models? So maybe you could also specify a little. Because again, using the tools is a part of it, but let's say in the agent architecture, you would like to use all memory, tools, reasoning, and actions. True AI, this is interesting. Private GPT, I even haven't heard about this one. Medical companions. Nice. It's really good to see that you guys are already experimenting with agents. No, so basically it's good because many of the things that I'll say, the language will be similar and will be even easier to understand. This great. And I would like to continue. And to continue with the first notion, okay, before this first notion, if you want to follow the project and do things with me alongside, you can check the link to the GitHub above in the Zoom chat. So there are collab links, and they include the libraries you need to install. The only thing you will have to add, and hopefully you'll have access to this, is you need to generate OpenAI key. I hope you have some, but also need to generate Tevili search engine key, Langchain API key, and weights and biases is not necessary, but at least Langchain and Tevili. And here in the Git, you'll find the links to the search tool and Langsmith. You can do it in 2 minutes. You just open the link, register with email or GitHub, and it's done. It's literally takes 2 minutes. Then you copy in your config, so you'll be able to run things alongside, or you can just do it later. And I want to start with the reasoning engine, because this is something what appeared in the very first weeks and days when public chatbots were released. People already started to hack in the reasoning of the large language models. So maybe you remember some examples like when people are asking ChatGPT to disobey it, to make some, to create me some illegal substances, or to be rude, or in any way, basically to hack its reasoning to follow your goals. So basically it's about planning, reasoning, etc. And more recently, there were not many, but several research studies that say, look, if you promise the chatbot, I'll give you a tip. Or for example, if you start to threaten it, I'll delete you if you don't make this task, your performance will be higher in terms of different metrics. So all of these are different ways to hack the performance, but the most structured way and well-researched way to do it are different prompting techniques. And one of the core, let's say, and most influential technique, at least to my knowledge, is chain of thoughts and tree of thoughts. So compared to a simple question and answer that you can ask LLM to do, you can ask LLM to think in terms of different steps. So you define in your prompt a chain of steps it has to do. Basically, that's like chain of thoughts. And when it will be able to make this kind of reasoning, thinking step by step, the output, the results will be better. There are improving techniques, chain of thoughts with self-consistency, when you can generate several streams of thinking. So not just one stream of steps, but let's say a couple of alternative streams of steps. And then you ask them to make like a majority vote to understand and to reason which of those streams is better, and then synthesize them. And the most generalized quintessence of this is tree of thoughts. So actually you can make and have many branches of thinking to get the potentially best output, which is really correlating with computer science theory. And you can make all this kind of breadth and width first searches among your reasoning, but we will not go that deep into this. But it's important to understand how we can actually implement tree of thoughts. And and of course we'll do it with the Langchain as promised. And the first thing I want to introduce you is how to work with prompts systematically, because I see that many people, just put the prompts right in the code, and then it's becoming a mess from the engineering perspective. And we need to introduce some kind of ML ops, or more fancy term, LLM ops, basically operations tool. And if you use Langchain, the easiest option for you will be to use Langsmith. And basically, you can connect it to your work almost automatically. You just need to define the key and allow it to trace your Langchain work. And if or when you register in Langsmith, you'll have access to some kind of like a hub and projects. So in your hub, you'll be able to study prompts of other people, but also write your own prompts. For example, this is you see chain of thoughts that we'll define right now that has even 4 steps. And this, for example, step 1. And this is how your playground is going to look like. You can define a template. For example, like I have a problem related to some input. give me 3 distinct solutions. This 3 also can be a variable. I can make it as one of the inputs, and it can be 3, 10, whatever it is. Also consider some factors as the input, and then it should start branching the answers. So you see, I'm already building a tree of 3 different branches of thinking. And the Langchain will immediately automatically parse it into different inputs. Also, you can have more complex things here, and you'll dive into this later. But the idea is that now I can have, you see, there is even commit button. So I can work with here as the version control of different prompts. And this is, for example, first prompt. I wanted to generate different branches. The next one will be here. For example, for each of these branches, evaluate the potential. Think about pros and cons, assign a probability of success, blah, blah, blah. Okay, the next step. The next step, it will be for each solution, deepen the thought process, generate potential scenarios. So basically for each branch, I ask it to think more. And then in the end, I'll ask it basically to rank those solutions, provide justification, and give me the final answer, what is the best. So basically this is implementing the something between chain of thought and tree of thought. Maybe even we can consider this chain of thought with self-consistency, because I ask it in the end is parallel streams, and then we ask it to make some kind of a voting. But the good practice is here that we use LLM system, operation system, to track all the prompts separately. For example, if I want to improve some of these prompts, I can do it here in the playground. I can commit it. I can branch versions of the prompts here. And let's, for example, just load those prompts. Then basically I turn them into subchains with different, you see, output key, what they should output. I combine them in a sequential chain using Langchain combination. Here are the inputs, here are the outputs. And this is example from the tutorial I mentioned above. Let's branch some solutions for human colonization of Mars. And some factors can be distance between Earth and Mars, and resupply, etc., etc. Let's run it. And again, why it's important to have some kind of MLOps, LLMOps operation system. Yeah, of course, within this notebook, I'll be able to read the reasoning here. Right now, it will start thinking, and hopefully it will output something. Yeah, okay, even finished chain. But you see, okay, it gives me some answer here, but it's really uncomfortable to read. And also, I cannot really trace the thinking logic. But I can go to my LLM ops system. I could have even defined a separate project, but it's all in default. And here I see my last sequential chain run. What is the input? What is the time? What is the latency? I can also track here my costs for all the projects or for a single project. And I can even go deeper inside. So here are my 4 chains. I can study them one by one. So for example, here is like step 1. Here's the input, and what's the output? You see, develop habitats on Mars, system of cargo missions, utilize resources on Mars. Those are the 3 branches it defined. Then it started to think deeper about those branches. 1, 2, 3, probability of success, 70, 80, 60. Then it starts to add more reasoning about those 3 branches. And then it starts ranking them and giving the final thoughts. So what is interesting here that I have broken up myself, the thinking process, into clear steps. And now I can basically do divide and conquer. I can optimize each step separately. I can study the results. I can study where I don't like the reasoning, and I can fix it back in the prompt. That is also, I can add another version of the prompt. I can treat my prompts as a version control and work on the project in a system. Because compared to the baselines and standard tutorials, I could have, writing all the prompts here, save it in, God forbid, in the notebook version, which is a mess. And this way is a nice, easy, structured way to work on the reasoning of the models. So this is basically how you can design your own. If you go back to the our architecture, this is how you basically work on the reasoning. And this is how you design it. This is how you do version control. This is how you track it systematically. There are some reasoning systems already available in Langchain. In the hub that we saw here, there are many people sharing their work. So, for example, maybe you heard about the React prompting technique that we also look into today. You can just load it from the hub, the same as, for example, some self-ask technique. And you can see that it will, maybe let's even do like this to make it easier to read. So you see it's adding a pattern that looks like this. You have access, it's already thinks about access to some tools, which will be needed for us later. And it's showing some kind of format of thinking, which also we can design like this. And then, question input. And also it's adding another variable, which is called agent scratchpad. We'll look into this also a bit later today, but this is one potential structure for your prompts that is using some tools. And this is interesting, another structure that is shown first in a few shot manner some examples of the thinking. So for example, if you want to ask questions about some facts and you want to build some chain of thinking. So if the question is who lived longer, Ali or Turing, first you need to separately find information about when each of them was born and died. And then based on this chain of thinking to give the final answer. So you can define it with the tools like it's done here. You can define it as an example of thinking and to make your language model to follow this thinking. So basically this is how you design the reasoning. You can design your own chain of thinking and track it systematically, or you can get inspiration from the hub of other approaches. Also here, I mentioned a couple of papers you might want to read about even further approaches, but we can keep it for this small homework. And I have a question for you guys, and Nata, maybe you can also share this pretty word cloud. What are your favorite and interesting prompting, chaining, reasoning techniques? Thank you. Provide context. Actually, context is really good example, and let's right now dive deeper into the context part. Nata, can I pick up with the screen, please? Because the context, I would like to generalize this term a little bit, because right now we discussed the reasoning. So basically we see how we can design our own reasoning, how we can do it correctly with MLOps practices. And we also saw how we can pull already some available reasoning techniques from the Langchain hub. The context is interesting question because I think we can generalize it as a memory. And when we go into the memory part, it's only natural to make connections with the human memory. And if we take really simplistic cognitive science approach to human memory, we have sensory memory. This is really momentary. For example, I can hear you, you can hear me, I can touch something, I can see something. So it's a momentary sensory memory that is basically input to mine and yours brain neural network, not only brain, neural network in general. And the sensory input we can compare to the prompt. So basically every time you give the input to a model, it's in a way it's momentary. You give it, and by default, if you just take a raw large language model without anything around it, it will be practically almost forgotten. It will be input, output, that's it. Then there is a short-term memory. When you work on something, even in like we are talking now and I'm explaining something, I keep something in my working memory. So for example, obviously I have the notes next to me. I remember what were your questions. I remember what I was talking about 3 minutes ago. So it's my working memory. And in terms of language models, and this is something what we are also familiar with even ChatGPT or other chatbots, it's the history of this particular chat. So when you're chatting to any kind of chatbot, it typically remembers what you discussed before. And that's why when you ask it, for example, oh, fix this answer, make the summary longer, make it shorter, pay attention to this kind of details, it is able to use this working memory, which is basically your previous inputs and its previous outputs as a chat as a whole, to give you the next answer. This is short-term working memory. And then there is the long-term memory. A long-term memory, this is something what I think someone who said about the context meant by it. In our brains, we have declarative and procedural memory. So declarative, it's something like memories. Basically, I remember some passage from the book, or I remember some scene from the movie. It's just like declaration, scene from the movie, something from the book. Procedural is more like algorithms and instructions. So it's less explicit, it's more implicit. For example, I remember how to run the code in Jupyter Notebooks. Obviously, I don't remember the declarative step by steps. I open the link, blah, 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 but I have procedural memory of how I run it. And typically we add this to the large language models via data. And how we work with the data, we either train the model from scratch, but we don't really do it often in practice. Sometimes you want to fine tune the language model or any other model with the new data. Can be relevant in some specific domains. So for domain adaptation, fine tuning can be really useful. But in most of the cases, we just add the data and this long-term memory via retrieval augmented generation framework. So let's say we want to give it some declarative memory of some book or some tutorial. So what you do, you get the PDF, you throw it to the Langchain parser, you define your splitter, you split pieces of the book into your database, you vectorize it, Pinecone, ChromaDB, whatever you use, and then you pull the needed context based on your question. So this is how you define this context. So having those different pieces of memory, you are most probably familiar with them, but I would like to structure them in such a way and show you how do you structure the memory in Langchain. Because again, when you think about the agents, I find having this architecture is important. So even, for example, when you design your own prompts, your own reasoning, having this kind of separation of memories, you can actually write in your prompts which piece of memory to access depending on the context. Because otherwise it's just blended. Oh, just remember something. No, it's not remember something. You can look for specific information in specific type of memory. So what is the long-term memory? I'll use a simple example of using our company website. And let's say I want to ask questions about it. So in Langchain, there is a web loader that is parsing the website. Then there is the character splitter. I'm not going to dive into this because most probably you already did it hundreds of times. But the logic is that you get the text data, you split it into pieces, you embed the data as vectors, and you store it in your favorite vector database. Could be FICE. It's typically done relatively quickly. And then when I want to get the context, I have some input as a question, and then I try to get this context as to get declarative memory to add it to my thinking. So say my questions about Neuron Lab projects in healthcare. And immediately can retrieve, for example, this creative practice solutions project, which is basically was a healthcare project. Then you can see about our article about remote patient monitoring with IT devices, also correct. One of the inputs, maybe it's not that relevant. And the last one is more commercial, but at least first two inputs that it got are correct. There are two healthcare projects. Of course, now you can say, oh, now we need to work on it. Yeah, you can make different chunk sizes. Obviously, I had to prepare the data better and clean it. Obviously, I might experiment with the chunk overlap. Maybe I need a better database. Maybe I need better embeddings. I will leave those technicalities as, let's say, further exercise as details, but this is how we get the long-term memory. And assume you know how to do it, we can see it works. What is the short-term memory? So basically, in our case, this is the working memory of our agent, the chat itself. And here we have a couple of things to know that are new. So I will pull one of the standard prompts from the Langchain hub. And as you can see, it has different pieces of the template. It has system message. And if you know that OpenAI likes to have something like a system message, that this is basically where you say, you're a helpful assistant, you're the expert in the website's parsing, you love football, and you always give precise estimates, something like this. This is how you define your prompt, your system first. Then there is a chat history. So basically, this is something when you already declare that you want to have some chat history as a working memory. This is something what it's not a default thing. So I had to load a specific template from the hub to enable it. Then there is my, of course, human message prompt template. This is my input, and we call it simply input. And then there is the agent scratchpad. This is a relatively new entity that is appearing only with the agents, because as we saw even in those simple examples, the agent is thinking. So it's thinking about how to separate the tasks. It is thinking about different steps. And this also has to be stored in a memory, because this is the working memory that our agent has to remember in order to give the right outputs. So if you have multi-step thinking, it has to remember previous steps and store them somewhere. So this is where we add this scratchpad. And this is default naming. Of course, we can change it, but here it is what it is. And often when you combine long-term memory and short-term memory, there is also like a new, basically design choice, the architecture choice. It's easier to use your long-term memory as one of the tools. We'll come into the toolkit a bit in basically 10 minutes, I think. But the idea is that when you need your agent to choose what memory to access, if you set up your memory type as a tool, it will be just easier to reason about. So in Langchain, you can create retrieval tool from your database, and we should call it, what should be neurons lab retrieval. That's neurons lab search. Any questions about neurons lab? We already defined it. And then how do we create an agent? So we define the core language model, the backbone. We define a set of tools, and one of the tools will be the long-term memory. We create the agent where we define what is our language model, what are our tools, what is our reasoning. As you remember, prompt is basically the reasoning. We define the agent executor, and here how we add a chat messaging history as a short-term working memory. There is a special class, chat message history. And in Langchain, you create an agent with chat history through this wrapper, runnable with message history. You define your executor, what is the history, key inputs, etc. And also then you can define the ID of your session, because in practice, each conversation has a separate ID. And you can start question, hi, I am Bob. Whatever. This is from the tutorial. So it starts it. And as you can see, it's having some kind of reason. It didn't look in the Neurons Lab database. It answered, hello, how can I assist you today? So it chose not to use any kind of tool. And let's test if it actually remembers that my name is Bob. So if I ask, what's my name? Your name is Bob. So basically, because this is in the working memory, it remembered history of conversation that you say that your name is Bob. So now it knows it. And of course, if you ask it something about Neurons Lab, what are neurons? Where is Neurons Lab? You see, it's invoking the tool, the long-term memory, company location. And what is the answer? Basically, this is our legal entity address in the UK. So it routed the question to the right type of memory. So you see, it can use both short-term memory and long-term memory. But what's interesting about Langchain, you don't have it for granted. So actually to enable long-term memory, working memory, and short-term, okay, just let's say working and long-term, you actually need to add it in code. And this is how it is actually done. Maybe guys, to make a small exercise, Nata, if you can share another questionnaire, maybe you can share another kind of website you would like to parse, maybe not a big one, and some questions you want to ask to it, just to to see that it's actually working. Okay, I got one. Heroes Karoffi. Let me share my screen. And I'll add it here to parse. So this is the website. Let's see. Okay, seems like it's parsed. And what questions they want to ask, because you know better what the website is about. Question about music. Okay, let's do this. What are the musical tastes? Okay, so first it finds about basically the genres, rock, jazz, classical, but I think it's a mixed one. Then cinema, art, cinema. So I see exactly the musical ones, at least the retrieval. This is how we're checking the retrieval. But let's also try to use it as the agent. But most probably, if the retrieval doesn't work well enough, then the answers also most probably won't be correct, but let's try. And the question is, and I'll just rerun it all. Loading the website, example of pulling the data, not ideal, but let's plug it all into an agent. And let's see what is the answer. You see, the answer that is used to generate is a bit more logical. Rock, jazz, and classical. Knows expertise and passion, this music genres. This is it. So even if the retrieval is not ideal, but we talk about the retrieval augmented generation. So it pulled this data to try to generate a reasonable answer out of it. And just a reminder, we can also trace all this, everything what we ask here in our LLM system. So you see it knows that we're using this tool of the database memory. And it knows it has to use this knowledge base. And this is what we pulled. See this, what it decided to pull as a similar information. And based on this, it is given the answer. So again, it's not really comfortable to study the performance in basically in the IDE, but here we can see it, we can check it, so we can see that okay, our search wasn't good enough. So now I can go back here and start working on the memory. I can on the long-term memory. I can filter the data better. I can do other chunks, etc., etc. Again, I don't know what is the real issue, but at least I could identify what's the reason for the issue. So this is the memory part. Let's go back to our architecture. So we discussed the prompting and reasoning, and now we can use MLOps system to track it. We added memory, and we added long-term memory as one of the tools. But of course, we can have many different other tools. And also, if you want to build some kind of a taxonomy of the tools we can use, tools can be, let's say, binaural, also we can say here, machine learning based or symbolic. So when talk about the machine learning based tools, you can invoke, for example, other large language model if it fits your purposes. For example, you can use, for example, how it's done in practice. For example, you know that some of your questions are easy, some of your questions are hard. And you know that for the easy questions, you want to use a cheap LLM. For the hard questions, you want to use expensive LLM that has more parameters, etc., etc. For example, you know that some of the questions require general knowledge, some of the questions require specialized knowledge. So for specialized knowledge, you want to use LLM trained on the medical data, on the legal data, whatever it is. So you can define this kind of routine. Some of the questions might require some predictions. And for example, for predictions, you don't want to use a language model. You want to use linear regression, gradient boosting, whatever you like. So if person is asking about something about your database and asking to predict something, you can't rely on the LLM to build a prediction. You actually need to fit some prediction model and invoke it and then get the answer. Or the tools can be symbolic. It can be some kind of algorithm that you write, for example, some mathematical calculation. We know that LLMs struggle with mathematics. So you can route your agent to use a tool when the question is about calculations. For example, if you're asking about square root of something, don't let LLM doing it, especially some cheap LLM or low parameters LLM. You can route it to your class with mathematical calculations. Or it can be some APIs, which can be APIs of automation tool, of internet search, your connection to Jira, to Slack, to GitHub, whatever it is, some kind of API. Or it can be some ChatGPT plugin, for example, whatever it is. So having this taxonomy of tools, let us experiment with this again. So we still need to use memory is retrieval tool. Let's keep it as one. And when we combine tools with reasoning, different prompts in the Langchain hub are designed to work with different tools. So basically, you cannot, at least when you do not design your prompt from scratch, when you're just using something from the hub, you should be really careful about what is used. Because, for example, there are some React document store, and if you, let's say, don't pay enough attention to details, oh, React is a cool prompting technique, but it can work only with one kind of tool, which is a database. For example, the same with self-ask research. Oh, wow, self-ask looks cool, but you cannot use it with the, let's say, some kind of mathematical operations. And so you can read more in the article I mentioned here. So be careful. Different Langchain tools and custom tools can work on or do not work with different prompts that are shared in the hub. But this is what you study by reading documentation. But pay attention to this because this is the mistake I did. I wasn't reading documentation. I was like, oh, React, cool, cool, cool. But then it doesn't work. Why it doesn't work? It's not designed to work with it. So let's define a couple of other tools. One can be the internet search tool. It's a Langchain partner with Stavely. So this is the tool, basically searching the internet you can use here. Let's make one simple case when you have an agent that with two tools. One tool is our database that we parse from a website or PDFs, whatever it is. Another tool is the internet search. So now the agent has to understand when I ask question about, let's say, Neurons Lab, should it look in the internet or should it look in our parsed information? And let's see if it's going to do it. So, but you see it has two tools in it. So, and you see I'm using a React bot that can use those tools. The specific type of the React, and if you remember, if you are planning, this is the one of the React templates. When decide what kind of reasoning you should do, and the bot knows that agent knows that I have access to some kind of tools and have to reason about those tools. So this is the technique we're using. And yeah, what do we have here? Oh, of course, some of this should have happened. Validation of retrieval input. So let's try again. Although Einstein said it's insanity to try the same thing and expecting for a different output, but let's add a little bit of insanity. And actually, this was a good bet, so now it could answer. So it can choose from two tools. And you see it's thinking, I should search for information about the services offered by NeuronSlab. I will use the NeuronSlab search tool. So it thought about it. It's invoking the right tool, pulling the information, and basically giving the answer that we provide services, AI solution development, fast-growing companies, blah, 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 specialize in different domains. But if I ask the question about what are the services provided by, I don't know, Facebook. You see, it's already using the Tavily search results tool. It's looking for different websites about Facebook, and then hopefully it will be able to give me something useful. You see, it mixed up. The search result will provide a clear list of services provided by Facebook. We can inspect the reasoning. Let's see why it happened like this. Maybe I don't think it's because of my typo here. So it decided to use the right tool. It goes to Tavily. It finds some information, and then what it thinks. The search results do not directly answer to the question about the services. So you see it tried different searches, and somehow after all the searches, it decided to use even the retrieval ones. It says it should try a different approach, and in the end got mixed up. So again, could be a way. So again, this is the question to the design of the prompts and design of our agent architecture. So if we expect that there will be questions asked about the services of different companies in our prompts, in our reasoning, we should separate the routing much better, because here I just use the standard prompt from the Langchain. And again, you see, it is not enough. I should have designed my own chain with much better describing the logic, and most probably could have avoided the mistake, but the standard prompt doesn't work here. But if I ask about question, let's say that is much more easy to separate. For example, what is the weather in Madrid today? I hope it will be confident about the search, does the search, which is the right thought. Let's see why it and where it got mixed up. I got mixed up with the other tool I'm using before. Let me rerun the code from scratch, because I used run all, and there is another tool I'm showing later, and it got mixed up with that. So let's say I'm just creating this search. Yeah, now it's correct. You see it found a location. There's the correct temperature. At least it looks like that. So this is correct answer. If it's easy to separate the logic, weather, and services of the company, of course it understands it easier. But if we expect the questions to be much more similar to each other, we should have designed our reasoning. Again, coming back to this architecture, reasoning should have been designed much better, because even I have correct tools, even I have correct memory, my reasoning isn't good enough. A question, is it possible to set a priority instead of a choice? Again, but priority, if you think about it, let's say semantically, is also about the choice. You choose one thing over another. So if you have a set of 3 tools, in your prompt, just like we have here, because right now it's using standard React prompt. You see here, it says nothing about the priority. It says that you should think about what to do, what action to take, here are your tools, but it says nothing that you should prioritize some tool over another if you meet this kind of question. Again, because the React reasoning from Langchain Hub is very simple. And that's why it's exactly one of the motivations why we wanted to share this webinar, to show you that you shouldn't always just rely on the standard prompts, standard templates, and you really need to design this agent architecture, because we have correct tools, we have correct memory, but with the basic reasoning from the Langchain Hub, it fails. That's basically example why it happens. And also I want to show you how to build the simple custom tools. Again, there the whole tutorial. I just want to show you that we can build a tool for some kind of Pythonic reasoning. For example, let's say I want to calculate the length of the answer. So just using the tool decorator, I can define it. You better define the types as well. So now I have a description of the tool. It knows the arguments. And now if I'll just add this tool, I have 3 tools now. So basically, I want to retrieve information. I want to search and retrieve information about my database. I want to search in the internet. I want to be able to calculate something. And now I want to ask question, find a description of Neurons Lab services and calculate the length of the description. So I want my agent to do 2 tasks with 2 different tools using a single prompt. And let's see if it will be able to actually do this. And let's go here. Oh, no, it's not the right one. Why we don't have it traced? Oh. Okay, so it decided correctly that it should use Neurons Lab tool to find a description and then to use calculate length tool to calculate the length. So this is correct, right? At this stage. It used the retriever. I hope that so you see what it found? It found this as a description that is super primitive and simple. So it seems like it's the retriever error. And then, so it didn't ensure that the description is correct. There is no guardrail. It now invokes the calculate length tool. It applies this tool over this very, you see, input, neuron subservices description. Of course, the length of this 32, but that's not what I mean. So even it found some kind of good description here, it still failed. So it seems like multi-tool use, it's not that easy for the agent, and we need to rethink the architecture more precisely. And this will be my basically next step and the last part what I wanted to show you today. Knowing those, it looks small, but those are mistakes that basically can really ruin your bot, your agent you're working on, if you just rely on some standard things. But before moving to final part, how do you actually design everything from scratch and kind of having things in mind, maybe you guys can share other tools that you would use in your agents. Maybe something that you already use from Langchain. I saw someone mention the SQL tool. Maybe something else. Maybe something from the ChatGPT, how it's called, marketplace. Also can be something interesting. Execute a Notion database search. Wow, Notion actually is really cool. And image generation tools, yeah, of course. And imagine how you can make an image generation tool that is self-reflecting. So actually you can be able to use external tools to analyze the image, to give the feedback about the image, and then use some reasoning. For example, you have some kind of hardcore rules that about the colors, palettes, or objects on the image. and you ask one tool to generate the image, then you go to your custom tool to validate the generation of the image, and then based on the feedback, you ask it to redraw again or just stop it. Types of databases, SQL tools. Oh, I like it. I like all of those examples. Thank you. And let's go to the final encompassing part. So now having all these pieces of the architecture, let's try to build a complete agent that has reasoning, all types of memories, different kinds of tools. And let's see how it's going to perform, if it's going to be better or no. So tools. And again, my recommendation when you design the agent like this is this using kind of first order principles. Like you can also separate it, of course, here for simplicity, everything in the notebook, but you can have like separate classes and separate constructors, for example, or factories, factory for the tools, factory for the memories, etc. So you can design your bots a bit more in a systematic way. So I'm offering here two custom tools. Again, they're just to showcase what we can do. For example, one calculates the length of the result, another calculates the uppercase characters. And the search tool. Again, just to have a variety of options to see if our agent will confuse among them or no. And you can have how many tools that you want. Now let's add all kinds of memory. So we'll add long-term memory and define it as a tool. Again, let's just use Neurons Lab website as an example. Then let's define a short-term memory. So actually to be able to have a chat, to give the feedback and to see if bot is able to react to the feedback. And when we talk about the sensory memory, let's also make a change to what was happening to the React. I'm going to use the prompt that is designed for the OpenAI functions agent. It is, and let's go to the hub and see how it looks like. It is important. There is important detail. Let's find this one. OpenAI functions agent. Yep. So let's see what is happening inside this prompt template. So inside this prompt template, the prompt itself is very simple. You can say you are a helpful assistant. It doesn't look as complex as all this React stuff. But it has the placeholder for the chat history, which will be a difference. It has placeholder for the agent scratchpad. So we'll be able to save more things in different kinds of memories. And this what can make a big difference. So sometimes you don't, instead of working a lot on the reasoning, you can add different kinds of memories. I mean, I'm saying you should add them by default, but let's see what happens when you combine all kinds of memories and very simple reasoning. And here's the list of the tools. This is how they look like, our 4 tools. Here we create the agent itself. I'm adding all tools, all memories. And so you can see the language model is the same. We are not making anything more complex here. And let's start chatting. So I'm going to say hello. It's going to say hello, how can I assist you today? And I'm asking find the description, basically the question we had before. And look what happened. Let's look inside of this prompt. So it goes correctly to the search, and let's see what. It created the correct answer. This is the. So it generates the correct summary out of this, and this is our input, and now it goes to the correct length tool, and is able to have correct input and correct answer here in terms of the length. So this is an example of how adding different types of memories, having scratchpad, etc., helps the reasoning. Because if you don't constrain your bot and help it to store more information, it can deal with it better. More context, just like someone of you said, more context indeed helps. So add this context. Now we're going to ask the next question was about the uppercase characters. For what I'm using Langsmith to check the logic, and you can in the GitHub repository you can check the links to the Langsmith here, and how to set it up. Also, you'll find it. It's very easy. It's just in the configurations. And I'm asking about the weather today in Madrid and calculate the uppercase characters. So it's supposed to use other search tool. So you see, but what is interesting, the history conversation contains partly irrelevant things. So it remembers, I said, hello, how can I assist you? Find the Neural Lab services. It answers with a description. I'm asking another question, and it ignores this context. It gets the weather in Madrid. It calculates uppercase characters, which is 1, 2. Let's check what it actually found as a description. One, two, three. 1, 2, 3. Okay, I calculated 3 uppercase characters, but maybe something wrong, or with me, or with the tool. But let's say close enough. Maybe C. C, Celsius. Of course, yeah, then it's correct. I missed it, yeah. So did it correctly. And of course, I can ask you to summarize everything what was discussed in the whole conversation. And it's just going to say discussed Neural Lab services, and weather description, blah, 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 blah. So basically what I want to show you here that when you design the agent, add memories, add different tools, and if you see that there'll be some mistakes, you can work on the logic itself, on the prompts, on the reasoning part. But adding memories like message history and scratchpad helps, because it's not just the scratchpad, it's not just about that. So basically our job here is multi-step. You want our bot to use different tools at different times. When we don't add this scratchpad, meaning we don't store it anywhere, yeah, the model will think, but it will forget about its thinking. So if you talk about our architecture here, not actually the memory, it has the working memory, but it has to be stored somewhere. Because yes, if you write a prompt and ask the LLM in a prompt to think, it's going to think, but it's going to forget its thinking going to the next tool. So you need to store it in the chat as a working memory, so it keeps the context. So if it's in thinking says, oh yeah, I go to the neural sub retrieval tool, I generate this summary, this what I retrieve for the summary, this has to be stored in the working memory. Because when we go to the next tool, which is calculating the number of characters or uppercase characters, whatever it is, it's going to use both sensory input, working memory, and the long memory. So this is really, it's easy concept, but it's really powerful to use different kinds of memories and not to forget about them. It's as simple as that. And the last thing I wanted to share with you is for some applications you want the answers that are structured. So when you're asking about some numerical things like number of characters or number of uppercase characters, whatever it is, what you really expect, you expect just a number, because then you need to store it in some database or whatever. So what you can do, you can define a structure. You can define it as a JSON. For example, I like defining them as a Python classes. For example, this is my desired structure. I want to store the question itself, the numbers from the question without text, and the text without the answer. And you can pass the structure to your query. So basically how you do it, you have a format instructions here. And here is where you ask about this format instructions. And then when you ask this question about, about services and length of the description, your output will have different fields. So you see it will have numerical answer 56 and text answer. This is the set of text answer. Okay, something happened in between. It somehow forgot about the 1 in 56. And I don't know why, but let's say it's close enough. So it could extract at least the 56. Maybe I should have described the better, because basically what it does, this is what is passed to the language model. And when I say text excluded, maybe this is what messed up with my answer here. So this is how you can also format the outputs, and having chat with your agent, you can get more structured outputs where you can have numbers and then push them to whatever structured database that you use. So this is a final part I wanted to share with you today. And as a summary, before we go to the conversation and maybe discussing what agents you are building right now, what you're working on, again, I'm coming back to the architecture part. And work on your reasoning. I still recommend having it structured by your own. So you can use a MLOps system, store it as a hub, define your own chain. It's always better than rely on someone else. This is basically your reasoning. Do not forget about all types of memory. There is the sensory memory, which is basically your prompt. There is the working memory, which is your both chat history and the agent scratch pad. Do not forget them, add them both. And then there are different tools that you also can define and use them correctly, etc. And yeah, I hope that after this workshop, and obviously you can go and check all the code and reuse it here. You'll have a better understanding, first of all, of the differences between the just a plain language model, RAG architecture, and the agents, and how more careful you need to be when you tune the agent compared to when you just create a RAG architecture. And I hope that having this structure in mind, you can work on your own agents now faster, easier, better. And thank you for coming.